I'm Stephen Foskett, the organizer of Tech Field Day. We're here in Austin, Texas with Platform9 Systems. Around the table are a group of independent writers and speakers who specialize in enterprise technology. They've been brought in from around the world to ask questions and learn about this technology. To find out more about Tech Field Day, go to techfieldday.com. And to see more videos like this, go to youtube.com/techfieldday.
Thanks, Cody. Once again, I'm Amrish from Platform9. I lead engineering there. The one key takeaway that I wanted to spend a little bit of time on before we move is that the kind of big deal here is that OpenStack is now a hybrid cloud management platform as opposed to being just a private cloud management system, which is kind of where we were when we last came to Tech Field Day about a year ago. So moving ahead, we now come to the next stage in the cloud infrastructure journey, which is microservices or containers. So as organizations are looking to exploit efficiencies more at the application level rather than at the infrastructure level, they're starting to use technologies like Docker containers. But in order to use them effectively, what they do need is a viable orchestration framework to manage all of these containers rather than just the containers themselves. As a rough analogy, you can think of container orchestration being to containers what IaaS was to virtual machines. So at Platform9, we've made a bet on Kubernetes being the leader in container orchestration for a number of these key reasons. Kubernetes comes with the project maturity of being the underlying glue that drives the internal Google machine. It has strong enterprise adoption. A lot of enterprises are using this in production already. And not the least of this is the community strength that Kubernetes comes with. This is evidenced in all of the usual metrics that you're used to, the contributors, the GitHub stars. But more than anything, you can see the pace at which Kubernetes has evolved and innovated over even the last year. So we're firm believers that Kubernetes is going to be the leader in this space. And we've kind of put our money where our mouth is. So we recently announced general availability of our Platform9 managed Kubernetes product, where we've kind of gone back to our old playbook of a SaaS-managed OpenStack solution and applied that to containers. So the Platform9 managed Kubernetes solution comes with pure play Kubernetes, which is SaaS-managed with the same 24/7 monitoring capabilities that we provided on the OpenStack side. It's fully integrated, runs anywhere. It's completely infrastructure agnostic. So you can run Kubernetes on-prem. You can run it on any public cloud. You can run it on any other clouds of your choice. So we believe we're the first company to provide such an infrastructure-agnostic Kubernetes solution. It also has support for creating highly available multi-master, multi-HCD clusters, which kind of form the basis for any real-world application that needs to be robust. The best part of all of this is that it runs side by side with managed OpenStack from Platform9. So you now have the same single pane of glass to manage your virtual machine-based workloads as well as your containerized workloads, which is key for a lot of organizations that are looking to do that as a transitional phase, moving from virtual machines to containers. So again, I'm going to spend some time with Cody going through demos. If there are any questions, I'll pause at this point. All right, we'll jump right into the Kubernetes demo.
Great. Thank you, Amrish. Again, I'm Cody Hill with Platform9, the lead systems engineer. And I'll be jumping into a live demo with Kubernetes as well. So let me move over to that workspace. There it is. So what we have here is the same environment, right? We're still in this PF9-Tech Field Day environment that we're running in. We're inside of that core site region and still inside that same tenant, right? So we're in the same environment. But we've used this switcher up here to move from the OpenStack framework here to Kubernetes, right? So if we want to get up and running with Kubernetes, right, we tried to make this as easy as possible, right? So we polled a lot of our customers and tried to find out how they were planning on using it. And funny enough, we were a private cloud company up until a few months ago, and then we started getting into the hybrid space. And I think a big driver for that was that probably 80% of our conversations around Kubernetes is people wanted to run that on top of public clouds, right? They want to run their Kubernetes framework on the public cloud. So what we've done here is created this cloud providers construct, right, where you can add your cloud provider into our Kubernetes control plane. So you can come in here and say, hey, I want to add a new cloud provider. It's Amazon in this case. Your credentials that you're going to put in here are going to need to have access to all of these Amazon services. So we're going to utilize the load balancing and Route 53 and all of these things to make sure this cluster is highly available, scalable, and ready and production grade, right? So punch in the name, access key, and ID, and you have a cloud provider. So now, if you want to create a new cluster based off of that, you'd say, hey, let's add a new Kubernetes cluster. Great. Do you want to create a manual cluster the old-fashioned way, or do you want to do this new automated deployment using cloud providers? So you choose your cloud provider. You'll see that it's querying the back-end cloud and says, hey, your access keys have access to all of these regions. What region do you want to create your cluster in, right? So we'll say, hey, let's do US West 2, right? US West 2 is handy. I like it. It has a couple availability zones there. So then we're querying US West 2 and saying, hey, how many availability zones do you have? Oh, well, I have 3. Great. So we grabbed those 3 availability zones and said we want to use those. If you say, hey, look, I'm not a fan of 2B, for whatever reason, you can pull it out, right? But the more availability zones your cluster spans across, the more highly available it is. So you'll choose that. Give this thing a name, right? So how about TFD cluster? And we're going to choose the size of our systems, right? So I'm going to choose a T2 medium for our Kubernetes master nodes. These are the nodes doing a lot of the orchestration, the service load balancing, and all of that. In most cases, unless you change our default behavior, these don't run containers on them. They're more of a brains, right? And then you need to create your worker nodes. Well, I want my workers to be a little more beefy. Let's create a T2 large for my workers, right? Because that's where my actual work's going to get done. I need to pass an SSH key to these so that I can connect to these instances. After all, these are your Kubernetes nodes. You should be able to get to the console of them and log into them. So we're going to pass your SSH key to them. And how many workers do you want? I'll say, for now, I'll stick to two additional workers. So we need the 3 masters because we have 3 availability zones, right? And then we'll stick to 2 worker nodes for now, and we can grow that later. So we need to choose your Route 53 domain in Amazon. Anybody using Route 53 here? And anybody who's an Amazon admin in the room? Anybody? Nobody uses Amazon Web Services. All right. So Route 53 is DNS as a service, right? It can create DNS names. It can do location-aware DNS routing, latency-specific stuff. It's really cool, right? So if you have an application that's spanning the globe, you can put that up. You can have Route 53 route your users to the right endpoint that's closest to them, and it handles all that magic for you, right? So this is a Route 53 domain. We own cube-sandbox.com. I bought it because we were doing a demo, and now I use that for this. And you can use the existing VPC that you already have, or you can create a brand new VPC to dedicate this cluster into. So we'll do that. We'll create a new VPC. And then anybody familiar with privileged containers with Docker and Kubernetes? You need a container that has access to root, right, to run things at the low-level operating system level. You need to enable privileged mode inside of your cluster. By default, we turn that off. If you need to do something like install sysdig or something like that to be doing monitoring of your containers, you would check that checkbox. And let's go ahead and create this cluster, right? So this is actually going to go out to Amazon, spin up some instances, create elastic load balancers, the Route 53 addresses, the VPCs, all of the widgets that you need to make Kubernetes highly available, scalable, and awesome, right? So that takes time, 15 minutes or so. So we're not going to wait for this cluster to finish. What we're going to do is jump into one of the existing clusters that we already have. So we have a cluster that's running inside of our own local data center, right? So we do on-prem deployments as well. I have one that I already built inside of Amazon to show, look, it's there and it has a nice green check mark and it's in Amazon and it's happy. But if you wanted to jump into, we're going to be doing our demo today on a local cluster, right? So we could jump into the dashboard of this cluster. This is the Kubernetes dashboard that's baked into Kubernetes. We're actually connected to those masters, and it's showing us this. So that's kind of cool, right? So we have access to that. we can jump into the Kubernetes CLI right from our UI. We can hit that CLI button on any cluster. And if you just want to run a quick few CLI commands to see how things are working, like how about kubectl get nodes, right? Tell me all the nodes that are in this cluster, right? Simple command for Kubernetes. Hey, boom, you have 2 nodes inside this cluster right now. So that's great. I have 2 nodes in this cluster, so we can jump into the CLI. And what if I want to expand this cluster? Let me go ahead and attach a new node. I have a kube03 node waiting to be part of this cluster. So let me go ahead and attach that right now, right? So I can say, hey, let's attach nodes. And this will call out to our Kubert API that we have. And it actually, anybody a 1980s gaming fan? Kubert? Yeah? Yeah, so is our chief architect. So we have our Kubert API that will create clusters for you, add nodes to those clusters, pull nodes out of those clusters, and all of that. So this is normally very quick. I don't know, is LTE failing? Ooh. Nice. That's lovely. So adding a node to the cluster right now might be a problem, but we'll move on. So that should be fine. I really hope that doesn't affect my next demo. So you can expand and contract those clusters, right? And then we have the ability to look inside of all of these clusters and see which pods are deployed. So if I grab my HA cluster that we deployed before, maybe I have a namespace here that I want to look at, and I can see what pods exist in that. So you have visibility over all of the clusters you have. Again, we have multi-tenancy where you can create namespaces in these clusters, create a user or a group, map them to that namespace, and they're locked inside of a Kubernetes cluster, so they can't affect their neighbors, right? So all that's built into our product. And now we're going to jump into, and please, any questions that we have would be lovely. So we have an application here, right? It's running on an embedded, we're simulating an embedded PC, right? One that doesn't, it's so small it doesn't even have its own hardware clock, right? So it needs to call externally to get time, okay? So we're going to deploy an application here. So I'm going to run a kubectl create -f deployment.yaml. Okay? So this deployment.yaml tells us how to build our Kubernetes application, right? Similar to the OpenStack deployment, where we had that long YAML file that deployed all those different widgets and stuff. We're doing that inside of Kubernetes. And you can see here that, let me make this a little bit bigger. And maybe that. Sure. So it's getting the current time, and you can see that it's getting the current time from the actual pod, time-server 2118, yada, 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 right? So that's coming up. And Kubernetes, with a deployment, we say, hey, give me, this deployment saying, give me 1 pod to get time from. And it's querying time 3 times a second, and will update itself. But what happens if that pod goes down? Right, so let's do a kubectl get pods to list out the pods we've deployed. And let's kill that pod. kubectl delete pod. Okay. Anybody know what's going to happen when I do this?
Pod just might be deleted.
It might be. What's going to happen after that? I did not enable HA. Kubernetes does that for you. So we lost time, right? Pod went down, we lost time. But the deployment's smart. It knows, hey, I'm supposed to have 1 pod running. You killed my pod, knock it off. And it starts a new pod. So we're representing different pods here in this demo with different colors, right? But you notice that when we killed that pod, we actually lost the application. The application went down, it recovered, but that's not a cloud native cool app, right? We need this, like this time. Time's important, we need it to be up, right? So let's scale this up for a little bit, right? So let's do a, let's see, scale. There we go. So let's do a kubectl scale dash replicas equals 3 on that system, right? So we say, hey, it just scaled. And in a minute, or a few seconds, you'll start seeing different colors pop into this, right? So now we're hitting different pods, and Kubernetes is load balancing these back and forth. So you can see we have like a magenta color and orange and blue. So now we're querying all these different services to get time. So now, when I come in here and do a kubectl get pods, and I say, hey, let's do that delete kubectl, delete pod. Let's grab the one that's been up for over a minute. Why not? So this, I think, is represented by the orange color. Let's delete the orange pod. All of a sudden, we're no longer getting responses from orange, but we didn't lose any calls to the back end. Kubernetes realizes that's gone. It is routing to the existing pods. And then what happens, right? The deployment goes, I need 3. You told me 3. You killed one. Knock it off. Let me create a new one. So now we have green, right? So green is now the new color here, right? So, and this little window down here, I didn't get the third node in here. It was supposed to, when I flipped to this, show you that node being added in. Right now, I'm just doing a loop querying for new nodes. And it would show it jump into the list, right? So right now, I only have 2 nodes. It would show a third node in the list. Not sure why that errored out. But we can now see, we have a little script here that will tell us which host, which node is mapped to which host, right? So we have these different pods. We have our, one pod is on 83, and then 2 pods are on 81. If we had the third host, it would be evenly distributed, right? So this little script does that. So then we can simulate an upgrade of this environment, right? So the last thing that we do when we upgrade an environment is we do a rolling reboot of the cluster, right? So your Docker runtimes get updated and all of that, so your pods on those will be evacuated and be recreated on the remaining nodes. So when you do this on a cloud-native application, right, we take one host down. You'll see it on the left. It's going to get marked for you can't schedule to it anymore, so stop scheduling to it. That's going to be the first thing that happens. Then it's going to start killing things, and the pods will then get created on the other node, right? So we'll run that. Let's then rerun this. Scheduling's disabled on the left. Everything just went blue. Application never went down, right? We're in good shape. Application never went down, but now we're locked to one host. If we had the other host in the cluster, right, we'd be in good shape. And then we created all the other pods. So now we're running here. We're in good shape here, and we've just demonstrated high availability with Kubernetes. This is the power of Kubernetes and microservices. Any questions on this and kind of how this works? And
so the one thought for myself, and I can think back to 2012, trying to do my first OpenStack install with Essex, and then having to learn how to commit one simple patch that took 6 months, spending literally a year and a half with other technical leaders and other business leaders trying to train people to be able to install and manage OpenStack. And what you're able to demonstrate right now, and that we're only in 2017, so this is what, 4 years, maybe, we'll say 3 years after we had completed the training on how to enable the people to understand how to do that, how that became OpenStack training around the world. You're able to demonstrate in a way that any single person in this room could create, deploy, and operationally manage, at least hardware failures is what I saw, that an OpenStack installation. Is that what I saw?
yeah, so on the OpenStack side, we showed the high availability on the OpenStack side of things.
Yeah.
And then this is on top of Kubernetes, which we are running a lot of those OpenStack services, like Nova and Conductor, in containers. So we can then do these rolling updates without downtime at all to OpenStack. Which
is what the community, and led by Boris and his organization, Morantis, what they led in the community put together. And it's really awesome to see you demonstrating that inside of yet another commercial product, showing your own individual value in that. I think what you demonstrated right now, and I walked in halfway through your conversation, I could sit down and take the steps that you showed and manage this.
Yeah, that's great.
It's really powerful.